Hello, Mr. Rana, right?
Yeah.
Okay, now look at this. We're given a few houses. And they are circular. But the problem is that we don't know how many houses are there.
Yes, we do. It's
No, look at this. There could be some here, but we only know they are less or equal than k houses.
It's a big house. How much triangles are there?
Yeah, we can talk about that next, okay? To simplify, we're given a few houses, but we don't know how many of them, right? And they are circular. What's circular?
In a circle.
In a circle. And then initially, the person here, Eric or Ryan, is standing in front of one house.
One house.
One house. And the house has the door, right? Has the one door. The door initially could be open or closed. They are less or equal than k houses. This is the upper bound. They could be less or equal.
What k is 0?
K is more than 0. That's a good question. That's a good point. Okay. So now we have the street object.
What if there are no houses?
Yeah, the k is 0. No, the k is definitely more than 0. Okay.
But what if there are no houses?
Then, good point. We come back to visit this corner case. We can open the door at the current position. We can close the door. We can check if the door is open. We can ask the Eric or Ryan to move left or move right. Okay. So now your task is to design an algorithm to count how many houses are there. We want to know how many houses by using these methods. Initially, the doors could be open or closed. They are no more than k houses. Okay. This is very important given conditions. We know there are no more than k houses. We want to know how many houses are there. So how can we design an algorithm to check how many houses are there?
I think you need to count. Do you check if it's open or just close it? No, wait.
Yeah, very good point. Yeah.
Because you can, in real life, you can maybe mark it or
Market, yeah, how?
mark it. You can mark it if opening or closing.
Yes, very close. It's
Because, for example, if it's open, you can close it.
yes,
And then if it's closed, then you can open it.
yes. Okay, so we can use the status of the door, open or close, right? So at the beginning, we need to do what? Because at the beginning, the doors could be open or could be closed. We definitely need to use the status of the doors. But at the beginning, the doors could be open. So the first thing is to
Check it open.
the first thing is to close it. But how do we close all the doors here?
Check if it's open.
Check it's open. How many times? And then?
No, check if it's open or just close it anyway.
Yeah. If it's open, we close it, or we can just close it anyway,
Is
right?
it possible to close a closed door?
Yes.
Cover it with close.
Okay, so we're here, right? So we close it, and what happens next? How do we close all the doors?
Go left or right.
Go left or right? Yes, and then how many times we need to go?
Less than k times.
K times. Yes, we're done. So we just go K time. Close all the doors. Okay, that's first step. And then how do we count? Now all the doors are closed. So how do we count how many of them? If it's a circular.
No, actually, leave one open.
Leave one open. Why?
And then you can go round and you see how many closed doors are there. And then the amount of closed doors are there, you plus that by 1 because there's an open door. So you can go round. You know how many times you're going around.
You're saying leave one open,
Yes.
and then you move here to until you mean this, right?
Yes.
Yes, that's a good point. If I at the beginning now all are closed,
No,
right?
but you don't know if you already have gone around once. You don't know if you have gone around once.
So why not? We just check if it's closed. If it's closed, we open it. We open it, and then we move left.
Yes,
If
that's
it-
what I'm saying. Leaving one open.
Then if it's open, then we know we have gone through one.
You're saying doing it all closed. I'm saying leaving one open, and that's basically it.
Yeah, it's the same
I
thing.
think
It's
you
the same
leave
thing.
one open, go around 3 times, and if you go back, you find where you are, you know how many.
Yeah, it's basically the same thing. The same thing. Okay.
Then why were you saying then why can't we just close it all?
Yeah, we need to close all of it.
Yeah. I'm repeating what you just said before.
Okay. So are we on the same page? We need to close it.
Yeah, you
Okay.
were saying that before you need to close them all.
That's right. Yes.
Why can't you leave one open?
Okay, I see your point. First of all, we close all of it, and then we open one, and then we go left, and go left, open it, and here
why can't you close the doors and also count how many doors?
Okay, but you mentioning a good point. So you're saying that so the doors could be open. So if it's open, then we close it.
My point was, why can't you leave one open? Because you say you have to close them all.
How do you leave one open?
You
Don't close it.
So you can open the door.
But at the beginning, you are standing in front of the door, which could be open or closed. So what I'm saying is that, okay, that's fine. Let's
Imagine-
close all the doors. And if you want to leave one open, leave one open. Because the first step is to make sure all the doors are closed. Okay?
Yeah.
Are we on the same page?
Possibly.
Now,
Everybody.
okay, so as we say, okay, we want to define count houses. Okay, and we're given a street object. At the beginning, we need to make sure all the doors are closed. So as we know, there are no more than k houses, so we can go through k times, right? For I, for underscore, in range k, and street, dot, close door, okay, close door. If street dot is door open, then we close it, okay? But for now, we can just say street dot close door. So I guess it's fine to close a door which is already closed. Am I right? Yes?
Yeah.
Okay. And now we do this. All doors are closed, right? And then now we need to count, right? So the answer at the beginning is 0, right? So where street is door open equals false. If not, why not? If it's not already open, if the door is closed, then we can plus equal 1. We have one door, right? And then answer. Okay, so there's a problem, right? Look here. So there's missing. We need to move to the left or right, okay? When we close all the door, we can move left or right. We do this k times, at most k times. We close current door, we move to the left or move to the right. Then this step, we closing all the doors in the street. If the current door is closed, we know we have one houses, and then we can move left or right. Move left or move right, it doesn't matter. And we need to open it, right? Open door. And then return answer. The second loop, the counter answer. If the door is closed, then we open it. We increment the counter. We move left or right. Yes? So basically, we're using the status of the door as a marker. At the beginning, we close all the doors. How do we do that? Because there are no more than k houses on the street. So we can perform this k times. To close one door, each door, move left or move right. Both the direction is okay. And then after that, all the streets, all the houses at the street are all closed. So here, we are here, right? So if the door is closed, we increment the counter. We have one house. We open it. We move to the left.
After you open the door and then you check how many closed doors are there, and then you plot that by 1.
Look, is it the same thing? Look, if the door is closed, I open it, I move to the left, I increment 1. This is the first iteration. You're saying, okay, leave one open here. I move to the left.
No,
It's the same thing.
I'm saying you count how many closed doors are there.
How do you count how many closed doors? You don't know, right? You can only move left and right.
Yeah, I check how many closed doors are there.
Yeah, this is what it is. How many closed doors are there? If the current door is closed.
I check if door is open.
Check the door is closed.
No, I'm checking if the door is open because you can check it if the door is open and then if it's not.
I see what you mean. Okay, so you're saying, okay, we intentionally open one door.
Yeah.
Okay, that's very good. So you're saying, let's open one door. Okay? And then here, we move left. And as long as it's closed, we move left. We don't bother open it. Alright?
Yeah.
It's slightly different. The first approach is that let's open the door. As long as the door is closed, we open it, we count it, we move to the left. Okay? And your approach is say, let's open one first. Let's open one. So it will be like 0, 1, 1, 1, 1, 1. And then move left. And then we count how how many closed doors, right? Until we reach the opens.
And then you plus that by 1.
Yeah, plus 1. That's very good point. You and me are on the same page by closing all the doors at the first step, right? Yeah? Okay. So look, the first step is to close all the doors, and then the next step is to count. And you're saying that, okay, let's leave one open. So you'll be like answer equals 1, and then let's say street dot open door. Open current door. And then we need to move left, right? Move left. Don't move left. Okay, move left. And then while street is door open equals false. While the door is closed, then answer plus equal 1. And then street door moves left. Alright? That's your approach, right?
Yeah.
Slightly different, right? Answer at the beginning equals 1. Let's open this current door. We move left first. Now we are at 1. When the door is closed, we increment the counter. We move left. The only difference is that you don't need to open the door here, but you need to open the door here. Yeah, we need to open the door because we don't have this flag, right? But here this is okay because eventually we'll come back to the first door, which already we opened it on purpose. Am I right?
Yeah.
Okay, the time complexity. Okay, right? At most k times. Okay, so what have you learned today?
Houses in a circle, and need to figure out how many doors are there. I mean, houses are there.
How many doors, how many houses? The same thing, right?
A house doesn't have a single door.
Yeah, but he said at the beginning, each house has only 1 door.
Yes. Okay.
But then that's not a house. A house needs
You
one.
need to close all of the doors. You deliberately open one. You
Move left. Yeah.
you move left, and you count how many closed doors are there. And after you count them, you plus 1.
Yeah. Count how many closed doors are there until we come back to the first houses we've already opened. Okay. Yeah. Okay. That's it for today. Bye bye.